Only three?
You to line back.
Acha. Okay. Namaskar. Good afternoon to everyone. My name is S.G. Belokar. I am a chemical engineer and I undergone training at BRC, then joined heavy water plants, and I worked in project execution, its commissioning, operation, and then subsequently I was working in the area of industrial safety, fire safety, environment protection, and occupational health. So uh, there are 7 water plants, and I was heading the safety, health, environment department, and retired as a senior general manager in 2018. Friends, it is my privilege to interact and to share my experience with all of you. I am proud to interact with some people from defense and police service. I salute them for their selfless service. I welcome you all. I understand there are few PG students, professionals from medical field as well as industries. I welcome you all. I hope I am audible to all. Now, secondly, I am really grateful to the management of Homi Baba National Institute Homi Baba National Institute for giving me this opportunity to share with you my knowledge and experience. The topic for today is management of hazardous chemicals. This is very important and very broad subject. It is important because everyone handles, uses, consume various chemicals day in day out. Be it a food, medicine, perfumes, cosmetic, clothes, or even the water which we drink, air which we breathe, all are chemicals. Uh, there are thousands of chemicals newly synthesized, manufactured, stored, transported, used, and those are in the form of solid, liquid, gases. They are either liquefied, they are compressed, they are stored in various forms in cylinders, storage tanks, etc. These chemicals are also of different nature. They are flammable, explosive, toxic, corrosive, reactive, and there are inert chemicals also. But many times, if we don't know the compatibility of the chemicals, then inert chemicals becomes hazardous. For example, if you use water with sodium, then it's a violent reaction generating hydrogen and spark. So uh, that's why everyone uses chemicals. That's why the topic is very, very important for all of us. See, most of us use LPG, CNG, PNG, petrol, diesel, police, defense, personnel uses explosives, doctor prescribes medicines, industrial professionals handle various chemicals as I mentioned above. Therefore, for safe use of any chemical, we must know KYC of the chemical. In the bank, without KYC, you cannot open the account. You cannot do transactions without KYC. Same way, before using any chemical, know your chemical very well. And the source for knowing these chemicals is material safety data sheet, which is readily available on Google. And manufacturers legally they are supposed to provide you the material safety data sheet. So during the management of hazardous chemicals, the first ever message is requirement is we must read, understand the material safety data sheet. What does it contain? It gives physical properties, chemical properties, toxic properties. Secondly, if there are emergencies like spillages, fire, or inhalation of the chemical, then how to handle those emergencies? These are also mentioned. There are certain limits prescribed for safe use like TLV, STL. Those limits are also provided. So knowing the properties of the chemical is essential before its handling. Why? See, the simple property, if we know most of the toxic gases are soluble in water. If we know, then in emergency, if we are trapped in a cloud of toxic gases like H2S gas, chlorine, if you put a wet cloth over your nose and mouth, you can protect yourself up to some extent. So that's why solubility of chemical in water is known in MSDS. Density of the gases. If you know whether the gas which we handle is lighter than air or heavier than air, how it helps? If you are trapped in a smoke-laden room during fire, how to get out of the room? If you stand, walk, and run, you will inhale smoke and you will collapse. But the smoke consisting of carbon monoxide, CO2, when it is hot, it is lighter than air, so it remains at the roof level. So the precaution, crawl down in the smoke laden room. So like that, uh, see if there is a oil fire in the kitchen, and in the kitchen, if somebody puts water over the fire, oil fire, what will happen? Oil is heavier than water is heavier than oil. So instead of extinguishing the fire, the oil will splash and the fire will be spreading. That's why the properties of the chemical which we handle must be known. Every household uses LPG, PNG, CNG. If it leaks, it's explosive. If it forms a flammable mixture, its limits are given, lower flammable limit, upper flammable limit. That is given in the MSDS. Now, being explosive, if it leaks in the house, it accumulates. And if we put on or put off any electrical appliances, it will form a spark and there will be explosion. So knowing the properties of the chemical and then do's and don'ts helps in preventing the accidents. So we must know these properties of the chemical which we handle. Whatever examples I have given, that clearly says that using any chemical without knowing the properties will be dangerous, and that is what is happening. For example, while cleaning the drainages or entering in an unknown area, people just enter inside the well or drainage and they die because they come across with toxic gas like H2S. So the point is we must know the properties of the chemical which we handle and its significance. Now, I will come across one case study based on which we will know how to manage the hazardous chemical. The case study is Bhopal gas incident, disaster strategy, during which thousands of people have died, 3,000 people have died reported, thousands have died prematurely. People become blind. Why? Because the methyl isocyanate gas was released at Bhopal in December 1984. The methyl isocyanate is a gas. About 40 ton of gas was stored in a tank, which was uh, intermediate chemical for making pesticide. Now, while storing this chemical, number one, the inventory was too large, being intermediate product. It should have been minimum. Earlier, they used to import small quantity and use it, but because of financial reason, they started storing large quantity. That was the first violation. Secondly, this is stored. It has vent scrubber system. In case of leakage of the tank, there was a scrubber system to neutralize the leaked gases. That scrubber was bypassed. There was a flare stack, long stack on the tank, through which all the gas can be dumped and burned. Flare stack was out of order. It was not in line. There was a refrigeration system to keep the temperature of the tank, but the refrigeration unit was bypassed. So all the design safety features of the tank were not in line. That was the first failure. During that night of 2nd December, the operator tried to flush one of the pipeline connected to the tank and flushing the pipeline with water. The isolation wall, which was towards the tank, was leaky. He has not checked. And water and methyl cyanide, they are incompatible. Water reacts violently with methyl cyanide and produces the toxic gases. So, during the flushing of the pipeline, about a ton of water entered in the methyl cyanide tank. Reaction took place. It was exothermic reaction and the temperature pressure built up. No cooling because the refrigeration system was out of order. Could not be vented gas, flare stack was out of order. Scrubber, which was there to neutralize the gas, was not in order. So ultimately, the temperature pressure of the tank increased and safety valve popped. Operator was not knowing what to do, and large quantity of methyl cyanide gas was released into the atmosphere. And this plant was old plant. Nearby, a lot of hutments were there. The gas release. They have sounded the siren. The people started running towards the siren. They should have run away from the source. Inhaled. Many died on the road itself. So this was the one of the worst strategy in the world. Uh, There are many lapses, but when the people started rushing to the hospital people were not knowing how to treat the patients. The owner Indian Carbide, they have also not given the information to the hospital. So there was chaos. So from this disaster, management of the hazardous chemical, what has happened? Now, where were the lapses? Let us see one by one. Number one, there was no regulation act for handling such large quantity of hazardous chemicals in India. So, safety and environment regulations for such industries was made after that in India. So, this was the one lesson. Environment Protection Act was enacted. Under Environment Protection Act, many acts were enacted. Uh, I will just list down, I will just tell you, various acts came after this accident. Uh, One is Environment Protection Act, under which the Environment Protection Rules, Manufacture, Storage and Import of Hazardous Chemicals Rules, then Rule for Manufacture, Use, Import, Export and Storage of hazardous microorganisms, hazardous waste management rule. So like that, number of rules were formed by the government. Even the clearances for establishing such industry was formed. Ministry of Environment Forest was established, uh, uh, and then uh, they many because of this because of the regulation, such incidences are now prevented. So the management of hazardous chemicals, the first requirement is you must know the applicable acts and rules, their requirements, relevant requirements, and we should implement. So that is a basic requirement. What are those acts and rules? Just to name few are important. In addition to the Environment Protection Act, the Factories Act, it is now amended. It takes care of safety, health, and welfare of the worker. So the requirements of Factories Act must be implemented. Under this, every state has formed the factories rules, state factory rules. Then there are uh, Explosives Act under PESO, Petroleum Explosives Safety Organization at Nagpur. So under these acts, there are many rules, explosives rules, the static mobile pressure vessel rules, gas cylinder rules, ammonium nitrate rules. There is a Petroleum Act. So like that, various acts are there under the Explosives Act. Similarly, there is a Water Act, that is to the Water Prevention Control and Pollution Act, the Air Act, that is Air Prevention and Control of Pollution Act, the Public Liability Insurance Act, the Atomic Energy Act, Electricity Act. So, before establishing or storing, handling any chemical, the relevant uh, acts and rules must be studied and those should be rigorously followed. Not only acts are minimum requirement. After that comes uh, uh, codes and standards, and then comes system. So, by based on the case study of uh, Bhopal gas strategy, the second is design safety features. Safety starts from right from location, then design, then during its fabrication, quality control, proper erection, and then commissioning operation. Various techniques are there to improve, to find out the slips, drawbacks, defects in the design. We must carry out risk assessment, hands-on study, and incorporate the required design safety features so that there are no releases of these hazardous chemicals. Then, after the establishment of industry, we must have emergency preparedness plan and we must carry out the rehearsals. Then manpower is most important. We should have train manpower. The required capabilities, their attitude, skill, knowledge should be adequate enough to operate the plant safely and to handle the emergencies. Procedures. We must develop these safe procedures which should be understood by the operators. And the lastly is safe handling of chemicals is continual improvement. PDCA, plan, do, check, and act. Huh? And while after doing this, develop the safety systems and improve the safety systems. Safety systems such as safety work permit system, training system, authorization of the manpower system, audit system. So these systems should be established and implemented religiously, and those are should be improved. And the most important above all is developing safety culture in the organization. Safety culture means working safely, voluntary, not under supervision. It should be our habit, and this needs change of mindset, training. Then only people change their attitude. Training is most important. Uh, they should know what are the hazards while handling the chemicals, what are the consequences, then what they should do, what they should not do. They should know the procedures, emergency procedures. They should be provided with PPE and they should be monitored. So there is one system like behavioral based safety. So such systems help in improving the safety culture and minimizing the accidents. So friends, our plants, heavy water plants where I have worked, I will share some of my experiences on this. Uh, this heavy water is produced based on two processes. One is H2S water process and then ammonia hydrogen chemical exchange process. At Kota and Manuguru, we handle about, at Kota 180 ton of H2S gas and Manuguru 380 tons of H2S gas at 18 kg pressure. Temperature it goes up to 200 degrees centigrade. And other plants at Thal, Hazira, Tuticorin, we handle hydrogen gas, ammonia at the pressure of 220 kg per centimeter square gauge and temperature from minus 30 degrees centigrade to 600 degrees centigrade. In addition to that, we handle LPG, chlorine, various acids, alkalis, solvents in bulk quantities. Now, our plants have been operating from last 35 years and there was not a major disaster in the plant during this period. So, the backbone is design safety features. So friends, I will just share some design safety features with the photos. Yes, design safety features, earlier one. See, yeah, just an introduction. These plants are outdoor installation. They are remotely operated away from uh, populated area, and now the plant is having remote isolation means any part of the plant equipment which is leaking or to be maintained, we can isolate immediately. If it is emergency, we can isolate immediately. Where they are remote operated valve, they are air motor operated valves, which I have shown the picture. Yeah, but this is the point. Yeah. Seal oil system. See, in our plant, for circulation of H2S gas, there are big centrifugal machines. So, for their sealing, no, sharp means for the sealing means the compressed gas should not come out. So there is a seal and there is a seal oil injected in the seal. Therefore, H2S will not come out. Next, there is a breathing air system. So, number one, in the control room, breathing air supply is there. It is a leak type. So that if H2S is released, it should not come inside the control room. Similarly, there are emergency shelters. If there is a release of H2S gas, then people are supposed to assemble in the shelters where breathing air is provided. Next. Yeah, these are the shelters with breathing air stored in the cylinders. Next. Emergency power supply. If there is a normal power supply failed, then there is a backup of class 3 supply, that is a DG set supply. Also, there is a battery backup supply, there are class 1, class 2 supply for emergency operations of the instruments and indications. Next. Yeah, as I told, there is a sealant system for walls mainly. Yeah, next. Yeah, firefighting system all over the plant. We are equipped with firefighting station, and not only that, wherever there is a chance of fire, fire water jets are provided. Next, fire protection system. Yeah, next. Yeah, there are fire barriers, etc. Next. Yeah, fire protection system, like there are H2S storage tanks. This H2S is soluble in water. So there is a fire water spray system that is called HELU system. So in case of leakage, the fire water is sprayed to minimize the release of H2S gas from the leak tanks. Not only that, the content of the tank can be transferred by gravity because they are stored in liquid form in the other tank. That is one feature. Secondly, the gas from the tank can be burned through the 120-meter tall stack and can be released. If there is a leakage from any tower, this tower can be emptied out and the gas can be safely burned at 120-meter height, and it will be released safely. Next. Yeah, there are flame-proof fittings, etc. So there is no spark in flammable area. Next. Fire protection system. Earthing bonding is provided where there is a chance of source of ignition, and also to take care of static electricity. Next. Yeah, fire alarm system. Yes, next. And as I told, there is a flare system which is very important. If there is any leakage from any pressure vessel or tower, the tower containing about 50 ton of gas can be released through the stack within half an hour. It can be burned. Next. So the design safety features are the backbone for safe operation of chemical plant, and these design safety features should be monitored and should be kept in healthy condition. If you see the Bhopal, design safety features were provided, but they were not in line. Now, to ensure that we have operational safety features, one is technical specifications of the plant. So that technical specification prescribes the monitoring and what is to be done if there is a failure or non-availability of the safety system. So that is very important system in our plants. Then training of the operational staff is very important. The requirement of the job and the compatibility of the and the compatibility of the operator should match. So we retrain to the staff regularly. Authorization of the operational staff is another operational safety feature. Every 3 years, we check the manpower or whether they are upgraded. At that time, we check their capability with respect to attitude, skill, and knowledge. Secure permit system is very important um, for safe handling of the chemicals. It minimizes the communication gap, ensure the safe working condition for taking up the work. Emergency preparedness. This is very important. We have got on-site emergency preparedness plan, off-site emergency preparedness plan, and with the rehearsal of this emergencies, we simulate such certain situations and check the responses, facilities available, and improve them. This has helped a lot. Regulatory inspection. The plants are inspected regularly by the regulators. Audits, safety audit, we do safety audit of the plant, whether the safety systems they are effective or not, they are implemented or not, what are the loopholes. So these are the operational safety features of the plant. And above all, continual improvement is important in the plant to improve the safety culture. That is most important. Next. Yeah, I think yeah, now go to. So, because of these safety features and maintaining healthiness of the safety systems, there are no major accidents. But however, I will discuss with you few case studies. Friends, there were this way. The mainly the accidents were workplace type, mostly fall from height, uh, then non-use of PPE, some flashovers, and these are main. There were few fatalities because of inhalation of S2S gas, but those was mainly non-use of PPE mainly. So let me just share with you some few case studies. Yeah, see, this is an old incident where the acid, hydrochloric acid, was stored in the tank, and because material of construction of the tank was uh, improper, it was a FRP tank, it failed, and also there were some design defects. So now this HCl tank collapsed. It is a very old one. Now we are having all rubber lined tanks, MS rubber lined tanks. They are lined inside as well as outside. Next. So see, the design process, their ladder was supported by the tank, experienced bending braking forces. FR tank was put in service instead of MSRL line. So there was material of construction was not appropriate. And operational errors, development of cracks when the tank buckled during operation. It was see, in these tanks, storage tanks, if you drain the tank without opening the vent, then vacuum is generated, and tank buckles, and it has developed that defect. Level measuring instrument was not functional. So there were other, these are the errors. During the operational life, the tank was filled completely for the first time previous day and has come under severe stress. Next. Yeah. See, this is one again acid tank failure. Uh, yeah, you can show this photo, upper photo. उसका ऊपर yeah. I नहीं. Okay, next. See, this is a bulk acid storage tank where the fume absorber is there because the acid releases the fumes. That fume absorber was located very close to the tank and it was not working. So it has corroded the drain point and the drain pipeline itself collapsed, and all the acid in the tank, about 200 metric ton, got released, and it could be collected in a neutralization pit. The picture of the drain nozzle is shown here. Just show the drain nozzle picture. नहीं, ऊपर 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 और ऊपर और ऊपर और ऊपर, हाँ ये नहीं, ये नहीं है, इसमें नहीं आ रहा है, नहीं, अच्छा अच्छा, ओके, हाँ, नेक्स्ट. So now we have made acid tanks as smaller tanks. They are rubber line inside, outside is a bulk tank. Next. So I will cover again. There was some acid tank failure because of the wrong material of construction. Next, next, next. Yeah, next. Next. There was a fire of H2S gas. The reason was defective gasket, improper flange joint, and uh, hydrogen sulfide forms iron sulfide, and high temperature, and the gas leaked and it got ignited. Now, one lesson which we learn is how to fight gas fire. Number one, we must stop the source of the gas fire, isolate the supply. If it is not possible to close the wall, isolation wall, inject the inner material like water, nitrogen. So this is the lesson we learn how to fight the H2S gas fire. We cannot extinguish the jet fire because gas is coming with the pressure. And if you put the water, maybe gas flame will be extinguished, but it can get reignited, or unburned gases will get released in the atmosphere and they explode and cause more harm. So it is not possible to extinguish the gas fire. The solution is stop the supply, inject some water, and cool the nearby pressure components. If the flame is touching with some pressure component which is carrying hazardous toxic flammable material, then that will melt and again the fire will increase. So cool the nearby structure till we isolate it. So this is a very important thing which we must know while fighting gas fire. Next. Yeah, next. Another thing, electrical fires. Electrical fires are caused mainly temporary connection, that is number one, and then maintenance. If the maintenance of the breakers is not done, then it has caused the fire. So entry of the lizards, etc., inside the breakers. The lesson which we learn is number one, proper maintenance of the electrical appliances, and then no temporary connections. Secondly, while fighting electrical fire, the basic rule is isolate the supply. That is important. In one of the incident, our people, they did not isolate the power supply because the plant can stop, plant can shut down. But that is not important. Fighting fire is important. So, irrespective whether plant gets shut down, we must isolate the supply of power. Power should be stopped so that the electrical fire will not increase. And then comes extinguishing the fire with some CO2. We cannot use water. Water is ultimately to be used only when the power is shut down. It is a de-energized. So, electrical fire, the message is very clear. Isolation is must. And then fight the fire. Next. So, there are certain human errors. This shortage of time. Yeah, next. So, see, there are two types of accidents: workplace injuries and the release of toxic gases. This is the most dangerous thing is if there is a release of toxic gas or fire and explosion, fatalities are more. So we have implemented process safety management in the plant, and that helps a lot to prevent the accident. So, so friends, the take-home message which I want to give within 1 minute is uh, safety is a good business. Whatever factors affect production quality, same factors affect the safety. If one takes care of safety, production and quality will be taken care automatically. Safety culture is a backbone, and we must inculcate safety culture in the organization. Uh, then, safety culture development means change of mindset, and that is always people should be trained. They should be told the consequences of their actions. Uh, prevention is better than cure. If you correct at the early stage, design stage, cost of you know uh, accident, cost of correction decreases drastically. So prevention is better than cure. We should learn from other incidences, others' mistake, huh? And that is how we can improve the safety. Secondly, toleration is violation. So we should not turn our blind eye if there is any unsafe act, unsafe condition. It should be brought to the notice of the concern, and till it gets rectified, we should continue to remind. So, lastly, uh, safety means what? S stands for system. System works. Individual cannot give the output. So respect safety and follow the system. Respect the system. What I mean is, in safety, S stands for system. System works. So system should be followed religiously. It should be improved upon. Then A. A is for attitude. We must have safe attitude. Whatever I am doing, it is for my safety. It is for the safety of my family. It is for the safety of my colleagues, and at last the organization and nation. So this attitude should be in the mind. Have fundamentals. We must understand the fundamentals. Whatever we do, as I told, if you know the density, if you know the properties of the chemicals, then you can take proper precaution. And T is time. Safety needs time. Time for training, time for procedures, no shortcuts. And ultimately, it is safety is for Y stands for you. So thank you very much. I can explain reply some few questions if they are there. Yeah. See, there is a break of 5 minutes and the next session will start. Yeah. Thank you very much for sparing time to listen this talk.
Good afternoon to all of you. I hope you have all very well in the examination of stage 1 and have moved on to stage 2 of the value addition course on disaster management, CBR and emergency management. I will discuss some of the topics closely related with disaster management. The topics I plan to cover in 2 sessions. Today we will discuss some of the topics and the remaining topics will be covered in the next session, immediate next session. The basics have already been discussed, have been covered in our earlier sessions in stage 1. We will take them forward in a bit detail in these 2 sessions, today and the next immediate session. All right. So I call it part 1 of the 2 sessions that I plan. Well, we will touch a bit basic. We all know that disaster management has 4 important phases. It starts with preparedness, mitigation. Now, mitigation is on both the sides, before the disaster and during the disaster, or before the emergency, during the emergency. Then response, and then recovery. Right. Now, these are all again the basics that disaster preparedness framework. We all know that preparedness is the key to minimize the emergency disaster effects. Now, these are the 9 important areas which are in the disaster management, disaster preparedness framework. Vulnerability assessment, important, planning, and then as per our Disaster Management Act 2005, institutional framework, then information system, that is efficient and reliable systems for gathering and sharing information. Then resource base. Now, resource base, particularly in CBRN, involves the availability of CBRN instruments, CBRN response, gadgets like PPs and various other things. Then warning system, a robust communication system is required for as a part of the framework. Then response mechanism established and familiar to disaster response agencies. Education and training is very, very important, followed by mock exercises, rehearsals, or let us say this is called tabletop exercises. Some of you have already worked in these areas. So these are the 9 areas: vulnerability assessment, planning, institutional framework, information system, resource base, warning system. Warning system involves early warning system. Then resource response mechanisms, education and training, and rehearsals. Now what we are doing, Agila is doing, is part of the education and training. So what is the situation of disaster in India? Disaster risk. Disaster risk in India are compounded by increasing vulnerabilities. How? These include the ever-growing population, the vast disparities in income. We have some very rich people, we have some middle income people, and we also have a large population of economically deprived or poor people who survive or who manage based on lot of support they receive continuously from government systems. Then urbanization, industrialization, and specialty of our country is, even if we know it is a high risk zones, we do not stop development and the population growth. Then environmental degradation, climate changes. Now these two last two topics, that is environmental degradation, climate changes, they have long time effects. Okay. So that means whatever has happened earlier, we are now encountering the effect, and whatever we are doing today, maybe in the years to come, the next generation or the other people will face the situation. Then all these point to a future where disasters seriously threaten our population, national security, economy, and its sustainable development. Therefore, there is a need to issue guidelines for the preparation of disaster management or disaster plan at every level. Okay? Every level means starting from lowest level to the national level. Just for comparison, I brought here for your just knowledge that in United States, there is an agency called Federal Emergency Management Agency. Now, this is also short for FEMA. Now, they are responsible for making policy and disaster management, emergency management related activities. They have a system, a 4-level system. It starts with personal level, local level, state level, and national level. Now, as the situation grows, it affects larger areas, it affects more number of population or property. In that case, the response mechanism also has to take care. So personal preparedness matters a lot for every situation. Even if there is a national disaster, national emergency, personal preparedness helps a lot in saving the life, property of the people connected, people affected. If it is slightly more involves more people and more areas, local government or local authorities or local system should be able to take care. Likewise, it goes to state level and then to national level. Now, this is just for example how American system works, because all the countries who are part of the UN system, they share each other's experience and pick up the points which are relevant for them. Now, disaster management coordination includes the strategies and actions to plan, prepare, mitigate, manage, and recover from major emergencies. Now, these two words, emergencies and disasters, they are interrelated, or let us say intermixing or interchangeable in this presentation, because you all know emergency and disaster difference. Now, emergencies include any man-made, also includes malicious act, or natural disasters that threatens or cause a loss of life, injury, and person's life. Responding to emergencies requires collaboration with a wide range of partners, including emergency centers, emergency managers, and everybody else, all stakeholders. Now, planning for disaster emergencies, that all these stakeholders, or they can also be called partners, work together to plan. That means any plan that is made to counter emergency for a particular area or particular population, it has to be planned together. Everybody has to be in the. So one of the important activities in reducing the risk of disaster. Risk plays an important role. We are going to discuss this risk again further in our discussion. Very important in any disaster management is one predicts, and then the moment something happens or something goes in the direction of emergency or disaster, warning is issued. People are given warning as much as early possible, which can save them or which is desirable. So the definition of what constitutes early warning, this word early is relative term. In some cases, warning of a few minutes or hours may be good enough. And nowadays, a lot of weather related emergencies like cyclone, flood, tornadoes. Now, these are all predictable quite in advance, and a lot of measures can be taken. Whereas in some cases, there is a big handicap, and the biggest handicap is earthquake. Similar thing is CBRN issues, which happens because of either an accident or leakages or releases or malicious act. Now, these are difficult to predict in advance. These things are only possible only when the situation sets in or situation worsens. The first component of an early warning system is risk knowledge, which entails producing risk information through collecting and assessing data on vulnerability, exposure, capacity, and hazards. The second is monitoring and warning, which includes observing, measuring, and predicting hazard events. Okay. The third element of early warning system is dissemination and communication, in which the earlier of persons involved or the authors create the warning message. Now, the warning messages also are very important because it should be clear, to the point, and do not leave to ambiguity. It should be as clear as possible. Mediators are the first receivers who broadcast the message to receiving population, and receivers, including at-risk population. Since early warning systems are only successful when recipients understand, that means whatever messages are given, the recipients are the persons on the other side, they understand. Then only it has meaning. And the fourth component is response capability. That means if the warning is given, the warning should also assess whether the other side or the responders will be able to respond to it. When effective, early warning system help protect lives, livelihood, and infrastructure. Okay, so that when effective means it also depends upon the preparedness. Now, this early warning system can also be integrated with the community. The community can also have a warning system that is called community early warning system, or CEWS, Community Early Warning System. When national early warning system disseminate warnings, they triangulate data with the monitoring of their own indicators and deploy early section where needed. For instance, communities along rivers, let us say there is a flood situation, those who are on the upstream can inform the people on the downstream side that the flood is inevitable. The flood, those areas will get flooded. It's let's say a matter of time. So they can be alerted and they can accordingly take safety related actions. Now we move further, that the risk assessment, the vulnerability, these are very important component of disaster management preparations. And the word risk is risk reduction or used loosely. That means it can have many vague meanings and inconsistently. Disaster preparedness is one. Basically, it has three main elements. That means many standard risk reduction terms are used loosely and consistently. Forecasting events and issuing warning. These are four major elements of risk reduction terms: forecasting, then precautionary measures, and improving response by organizing and strengthening capacity to deliver timely and effective rescue relief assistance. That means for risk reduction, for disaster preparedness, these are the three areas. That means forecasting, that means event forecasting or disaster early warning, precautionary measures. Now these are all important part of the preparedness, and improving response. Okay. Now these are same thing have been explained earlier, but now these are all the things being discussed in using different languages. Disaster preparedness has got two main aims: to help people to avoid impending disaster threats and to put plans, resources, and mechanisms in place to ensure that those who are affected receive adequate assistance. It is assumed that some people and property will be vulnerable to disaster despite mitigating measures. Now, this is very important. Whatever may be the level of preparation, whatever actions are taken at different levels, there are always some people who are more vulnerable. There are some properties which are all highly vulnerable. Now, these are all despite all the measures we take, despite all the mitigation measures we take. And the agencies or the disaster management teams will have to deal with these disasters impact. All right. Now, emergency warning system has, let us say, 4 points, connected points. One is risk knowledge. That means emergency early warning system, the system or the people handling it should have the risk knowledge. That means systematic collection of risk information, including hazard identification and risk vulnerability. Then monitoring and warning, risk detection and analysis, and hazard costing, including observation, measurement, and prediction. Then dissemination and communication. Okay. So warnings are drafted, that means warning messages are drafted and disseminated, and they are passed on by various means. For example, social media applications. Now, this social media has become very useful, though it is very recent, but it has become very useful in mass communication, in communicating people. Sirens, radios, etc., etc. Okay. Now, disseminate, and then the response capability. Now, response capability always plays a role, because whatever early warning systems, early warning communication is given, if the response mechanism is helpless or they are not properly equipped, then it may not be of great use. And the common alerting protocol, this portion has been discussed in the stage one of our lecture also. The common alerting protocol is a standard format for warnings and emergency alerts. When alerting the public, the information must reach vast numbers of people, that maximum number of people, and of course in that location, which is why it is also requires multiple dissemination methodologies. That is because some people are connected to some method, some people are connected to other methods. So this common alerting protocol tries to spread the information, tries to pass on the information, tries to do the early warning messages to as many systems as much possible. So some people may get the message double, 3 times, 4 times. But definitely idea is everybody gets at least once. However, it is key that all recipients assess the same key warning facts. Now, this is the commonality protocol, the message, one typical draft. That means it should have the draft sender's name, it should have message sent with date and time, identifier, provide a unique identification of each commonality protocol, status. Status means what is the status of the emergency? Okay, then type of message, state the message type, alert, update, cancel, like that means whether the message is just starting as an alert. It also happens, I have myself seen in so many places that the alert is given and after some time the message is uh, cancelled. That is because the weather condition sometimes changes its course. So it should be clear whether it is a alert message or there is an update, or at the end it is if the risk is over or the danger is over. It happens more with cyclone or flood type of situation. Then the category, these are the various categories like safety, security, rescue, fire, health, infrastructure, geological. Then here itself the CBRN thing will come. What the type of category? Then the message template, provide a headline, give a description of the risk information. Risk information, basic idea is to give to the public which they can understand. Then the priority, how serious and how significant the case is. All right. Now hazards overview. Hazard in any disaster management is hazard, location, vulnerability. These are very, very important. The location-based recovery plan strategy. In order to properly plan for recovery from a disaster event, if there is a disaster already, let us say envisaged, or let us say in the thinking, there is a postulation. The types of event that could occur in the location must be identified and defined. Identifying the hazards that occur along with the frequency and magnitude allows the recovery planning process to clearly understand the needs of the city, needs of the location of the city. In addition, a vulnerability assessment is used to quantify exposure and the potential loss estimates for each hazard. We move on to the next paragraph. The hazard identification and analysis of the location describe the hazards that pose a risk to people and property. We will take one small case study here for a location, for a place or for a city or for a population on the coastal area, or let us say on the sea coast area. Okay. So one typical case, suppose we are asked to make hazards overview, or let us say location based, situation based, and the type of risk for a particular location. How do we proceed? So this is a case. Let us say this was based on the data which was programmed in the year 2020. The results of the hazard profiling process were used to generate hazard classification according to a number, according to a number that is priority risk index. Now, this index, it has to be done very carefully, very wisely. That is because if this assessment is wrong, the whole output will be wrong, and then the preparedness will be badly affected. So this index, let us say the priority risk index, that means if there are different types of hazards in a particular location, how do you prioritize it? Which risk has to be taken as the priority risk for the purpose of preparedness? Okay. So this area and the conclusion drawn from the hazard profiling process for the locations, including the PRI results. PRI is Priority Risk Index, resulted in the classification of risk for each identified hazard according to three categories. That means that area has been, let us say that is our candidate area. We have tried to classify the risk of the hazards, vulnerability in that area, and it has been categorized into three categories. That means high risk, moderate risk, and low risk. Okay, we'll see it in the next table. So that area, I have told you it is a coastal area near the sea coast area, has the following risk. Okay, flood, events, tropical storm, hurricane, storm surge, extreme heat, public health emergency, wildfire, hailstorm, etc., lightning, corrosion, terror. Then Toronto, civil disturbance, drought. Then this is nor'easter, that is a type of storm. This is normally the word used in the northern Northern America, North America, on the, I think, eastern coast. And then sea level rise because of tide and because of effect. Then let us say even the a plane crash, earthquake and tidal. These depending upon the past data. That means past data is wherever it is available and how much it is available. That depends. So this data has to be understood very well. It has to be given due weightage for its accuracy, for its seriousness. So there, as per that exercise which was conducted, the high risk items have been listed like flood, thunderstorm, wind, tropical storm, hurricane, etc. That means basically the area is more into flood related or thunderstorm related emergency or disaster. However, the other type of, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are the 10 emergencies or types of disasters which have been brought into moderate category. But that area does not have a big history or, as per the data, earthquake. So earthquake has been brought under the low risk. If there is an aircraft crash, it is brought under the moderate category. If there is a commercial airplane crash, it has been brought under low risk category. Okay. Now, depending upon the weightage we give, that means how much it happens and how much is the impact. Okay, how much it happens and how much is the impact. Now these are the two important considerations. These are the two important parameters that makes risk as per the definition. Okay, so they have been brought under 5 categories. The high risk items: flood, thunderstorm, tropical storm, storm surge, and extreme heat. If you remember, these are the 5 types of events which are listed in the high risk item, high risk category. So these are the high risk category, emergency or disaster. And if by their own assessment or by the past data, they have been given the probability of occurrence, the impact of the incident, or the spatial extent, the warning, time and duration. Now, let us say, take a typical case of storm surge. Storm surge, as per the categorization, has been given the likely probability. Impact is critical, that means high impact. Spatial extent, that means the area, that means the geographical area covered. How big is that area? That is large area. It is going to cover large area. And the warning time is, but the advantage is you will always have a warning time of more than 25 hours. And the duration it will not last beyond 24 hours. So these are the 1, 2, 3, 4, 5. These are the 5 parameters: probability, impact, spatial extent, warning time, and duration. They have been given due weightage. And as per the weightage and as per the hazard, it has been given the it has been given the PRI of 2.9. Now let us see. There is another condition of tropical storm and hurricane. They also have got a similar damage, similar vulnerability, similar probability. It also gets the same priority risk index of 2.9. Okay. Take the case of flood. Okay. Flood. Now, flood, as per the probability, is highly probable. It has the same critical impact, but its spatial extent, that means its geographical area covered, is moderate. But it has a warning time of 6 to 12 hours, not more than that. See the case of a storm surge, where we get a warning of more than 24 hours. Here the warning time is only 6 to 12 hours in that particular area. This is a case of a particular area where the study is made. And the duration can last less than a week. So the priority risk index allotted is 3.3. Now, this PRI, how it is going to be useful is in disaster management. This is how you give the priority and make response mechanism according to that. And indirectly, it will also relate to how much fund can be given. Okay. So exposure to hazards can be an indicator of vulnerability. Now, economic exposure can be identified through locally assessed values for improvement. Now, this is all related to, the top important thing in disaster management is life, and the second thing is property. Now, this speaks quite well. This is quite related to economic criteria. All right, so now we move on to disaster management plan. Now, this is another topic, a rather discrete topic we will discuss maybe in 2-3 PPTs. Disaster management plan has got the following characteristics. Okay, they are: the objective should be clear, it should be realistic. Where are the weaknesses and strengths? DMP should cover it. That means the same thing we can always talk in terms of hazards, vulnerabilities, and PRI. That means priority risk index. The roles and responsibilities of all the stakeholders. Okay. The plan must be well informed. All relevant aspects like hazards, risk, vulnerabilities, and capacity should be included. It must prepare for extreme events and chaotic situations. Now, this is very relevant in our country, India, because the situation as it is in many places become very chaotic, and in a populous country like ours, this makes a difference because a simple emergency can get converted into a very serious situation just because of chaos. Let us say in a case where there is a crowd, if some situation maybe some even hoax situation develops, that can lead to stampede. So that has to be properly addressed in the plan. Okay. Then the aim should be to provide effective and timely response time. We all know that in the disaster or big emergency, governments usually take the lead in the disaster preparedness planning. But as in the other aspects of risk reduction, the plan should integrate the skills and capacities of a wide variety of agencies. All right. Sometimes it may happen that the agencies may come faster, or they may do a good job even before the government mechanism comes into picture, maybe because of various reasons. It should also encourage good coordination. There will have to be some center to coordinate emergency operations or disaster operations or management, but disasters cannot be controlled always in a top-down manner from a single point. See, big disasters like we were all experienced in this country, COVID, that started with a top-down approach, but slowly it mingled, and then it came to at every level. It should be owned by all the parties. All the parties means all the stakeholders. For the plan to work, people must believe in it and committed to it. The regular review and updating is a very essential part of any disaster management plan. So here we close the session 1, and I'm going to take some other similar related topics in session 2. So if you have any question, you can post it to us, because it may not be possible to take it now because of the time situation, and definitely we'll come back to you. So thank you very much. Have a nice day.